Welcome to Chemistry Plumber. Today we will see what is the magnetic nature. See, if all molecules orbitals, it is electrons are doubly occupied. This is called diamagnetic. Next, if single electron occupied, it is called paramagnetic. If double electrons occupied, it is called diamagnetic. See, magnetic nature. If we apply the magnetic field in molecules, this is going to attract or repel. Next, if magnetic field repel the molecule, that is called diamagnetic field. If magnetic field attract that molecule, that is called paramagnetic field. See below for understanding. If number of all are pair of electrons at bonding BMO orbitals and anti-bonding ABMO orbitals in one molecules, this molecule going to diamagnetic characters. If we apply the magnetic field, this is going to repel. These all are very important point. Please keep it in mind. Next, if number of unpaired electrons at bonding BMO orbitals and anti-bonding ABMO orbitals in one molecule, this molecule going to paramagnetic characters. If we apply the magnetic field, this is going to attract. See below. Here, see here paired electron, this is also pair, this is also all are pair electron, so this is called diamagnetic. This is going to repel. Here all are unpaired electrons, this is called paramagnetic. This is going to attract. See below. Let's consider based on the 5 information with the example. For example, O2 molecule, oxygen molecule. Now we are going to see 5 information for oxygen molecule. First one, nature of the bond. Second one, bond order. Third one, bond length. Fourth one, magnetic nature. Fifth one, stability. See, for O2 molecule, we know that oxygen valence is 6. Here, see the electron configuration 1s2, 2s2, 2p4. This is the valence electron. Now, 2 oxygen atoms going to overlapping below. See below the diagram. Please carefully in this diagram. If you have any confusion, see again the diagram. See here, this is the ABMO pi orbitals. Here pi x star, pi y star. This is BMO pi x, pi y. These are paired electron. These orbitals is unpaired electrons. See 2p orbital, here 1 orbital, next 1 orbital, here 2 orbital at x, z, y, x. See left side, here 2p orbital, here z1, y1, x, 2 electrons. See, this is sigma star z. See below, This is the p orbital combination in oxygen molecule. See below. This is the ABMO here. See here paired electron, here also paired electron. This is sigma, this is sigma star. This is 2s2 orbital. This is 2s2 orbitals. This is s orbital. See below. Next, see here, this is ABMO, here 2 electrons, sigma star. This is sigma BMO, here paired electron, here also paired electron. This is a 1s2, this is a 1s2 orbital. C. So O2 molecules, this is one oxygen, this is another oxygen molecule. See the electron configuration, 1s2, 2s2, 2p4. Here also 1s2, 2s2, 2p4. See, we will see whole diagram. See, wait, please. See, this is the whole diagram for O2 molecule. Please, if you have any confusion, please watch again this diagram. This is a very important. Next, now let's see p orbitals between the two oxygen atom, that is pz, px, py. See, this is the p orbital, this is also p orbital. Here 4 electron, here also 4 electron. Axis is x, y, z, z, y, x. See the diagram. See, this is the sigma star z. This is sigma z. See here, this is paired electron, here unpaired electron. See the diagram, please. Watch well this diagram. Please don't skip this diagram. Here one electron going to jump in this box. See, same thing here. This is the x, this is the y. See here, this one electron going to here. Next, this y one electron, this is this electron. Next, this one electron x, this is this electron. C. Next, this electron, say x, this is x electron. Next, this electron, this is the y electron. See carefully. Next, z electron, this is the z electron, this is the z. Here this is the Z. Please, if you have any confusion, see well the diagram. Please don't skip. Please watch well this diagram. Don't confuse. Just think yourself and watch again. For understanding, we know that first electron going to fill lower energy to higher energy level. Let's see at p orbitals x, y, z axis only, not z axis, because z axis head on overlapping, it is sigma bond, but y x axis sideway overlapping because it is pi bond. Please keep it in mind. This all are very important word. Next, see this diagram. Here this is the pi x star, pi y star. Here one electron, here one electron. These electrons going to jump in this box. These electrons also same thing. Here these two electron going to jump here. These two electrons going to jump here. Here see carefully, this is y x, so totally 3 electron. Here x y, totally 3 electron. This is higher energy level, this is lower energy level. See carefully this orbital donating the 2 electron for this. Same thing here. This orbital donating the 2 orbital here. Please, if you have any confusion, just watch again the video. Please repeat the 1 or 2 times in this video if you have any confusion. For fully understanding, please remain the Alpha principle and answer rule, Pauli exclusion principle. Please, if you do know these 3 types rule, check our channel or going to see your textbook. Next, from above the diagram, anti-bonding electrons as 2 electrons only, but bonding electrons as 4 electrons. First single electrons going to fill, then pair of electrons going to fill at a lower energy. See next next electrons going to fill at a higher energy level. So see the bond order for O2 molecule. We know the bond order formula, that is bond order equal of Nb minus Na. Here Nb is 10. So oxygen valence is 6. So 10 minus 6 equal 4. This is the bonding orbitals, sigma pi. This is the anti-bonding orbital, sigma star, pi star. See the diagram, please. If not see the diagram, you won't understand. Please see the above the diagram. Please don't skip anywhere. So 10 minus 6 equal 4. So according to formula of into 4 equal to 2. See cancel out 2 4 cancel. If we cancel 2 and 4, we get bond order is 2. So bond order value is 2. This is a positive. So this is stable molecule. Bond order between the two oxygen atom is 2. That is below. Here O2 molecule, O double bond O, this is sigma bond, this is also sigma bond. Magnetic nature for O2 molecule. See below. O2 molecule has 2 unpaired electrons. This is paramagnetic. Another example, C2 molecule, carbon molecule. We know that carbon valence is 4. See that electron configuration 2s2 2p4, totally 4 electron. See below the diagram. See here, see the diagram for carbon molecule. This is the sigma star x z. This is sigma star z orbital. This is empty. Here see pi x star, pi y star. This is also empty. Here sigma z. This is also empty. See the 2p orbital. Here 2 electrons at y x. Z is empty. Same thing here. So 2p orbitals. Here 2 electrons at x and y. So Z is empty. Here these 2 orbitals donating the 2 electrons. It is going to jump here. These 2 also going to jump here. So this is pi x, pi y. We already seen sigma bond, pi star and sigma star. Please, if you have any confusion, see our videos from chapter first lesson. See next 2s2 orbitals. This is the 2s2 orbitals. Here 1 electron, here 1 electron, here 1, here. So here both are equally. Next 1s2 orbital. Here also 2 orbital, here 2 orbital. This is sigma star, this is the sigma. Here 1s2, 1s2. See bond order. So bond order formula of Nb minus Na. So see 8 minus 4 equal to 4. So 4 is valence electron for carbon. So of into 4, if we cancel out, we get 2. So bond order is 2. So bond order between the 2 carbon atom is 2. So bond order 2 is positive value. So this molecule is stable. It means this molecule is exist. Next, magnetic character or nature for C2 molecule. Here all are paired electrons. This is diamagnetic nature. Bond length is shorter because double bond. So So big short, not big shorter, less shorter. Triple bond is will be very shorter. Single bond is longer, double bond is shorter, triple bond is very shorter. Please keep it in mind. Please subscribe our channel. We are making more videos for all chapters. Thank you all the best.